Hi, I'm Dr. Incognito. In this video, we're going to use part of the fundamental theorem of calculus to calculate the derivative of an area function. So an area function has the form integral from some number to x of f of t dt. And our question is, what is the derivative of such a function? The derivative could also be written d over dx of integral a to x of f of t dt. And part of the fundamental theorem of calculus tells us that the derivative of the area function is simply lowercase f of x. A here is a constant, x is the variable with which we are trying to differentiate, and t is a dummy variable, the variable of integration. So when presented with an area function, its derivative in this form, a number to x, integrand dt. The derivative is the same integrand function evaluated at x. So as an example, suppose a of x is equal to the integral from 0 to x of the sine of t squared dt. Then the derivative of this function, the derivative of the integral from 0 to x, the definite integral of sine of t squared dt, is equal to the sine of x squared. You just take this function here and replace the t with x. A little bit of justification for this, assuming that we already have the fundamental theorem of calculus that tells us the integral from a to b of f of x dx is equal to capital F of b minus capital F of a, where capital F prime is equal to little f. The justification is that the area function would then represent, according to this part of the fundamental theorem of calculus, would represent capital F of x minus capital F of a. And now if we want the derivative of that, the derivative of that would be the derivative of this right side, capital F prime of x minus capital F of a is a constant, so its derivative is 0, and capital F prime of x is lowercase f of x. Capital F prime is little f. Capital F is an antiderivative of little f. And this point of view helps us in slightly more complicated problems. Let's say that in our function a of x, instead of having the integral from 0 to x, suppose we have the integral from 0 to 3x of the sine of t squared dt. And now we want the derivative of this. In order to figure out the derivative, it might be helpful to imagine that we could anti-differentiate this function and get a capital F, and then according to the other part of the fundamental theorem of calculus, we would have here capital F of 3x minus capital F of 0. So that would be a of x. And now we want the derivative, so a prime of x is equal to get the derivative here, we need the chain rule. It's the derivative of the outside times the derivative of the inside. And this is a constant, so the derivative is 0. So we get 3 times capital F prime of 3x. So that's 3 times. Now remember, capital F prime is little f. This here is little f of t. So capital F prime is the function that we see as the integrand in the area function. So this would be the sine of, instead of t squared, it would be, we're inputting 3x, the sine of 3x quantity squared. And we could rewrite that as 3 times the sine of 9x squared. So that would be the derivative. It's the chain rule. Essentially, if you look back at the original problem, and the answer derivative of this function, this area function, you take the sine function, you put 3x in for t, and that gives you this, and then you multiply by the derivative of 3x, which is 3. And that's the chain rule. So one last example of this. Let's take an example where the bottom number is not a constant. So let's say we have the area function is equal to the integral from negative x cubed to 3x of the same sine of t squared dt. What is a prime of x? What is the derivative? So in order to find that, it's helpful to imagine that we could anti-differentiate this function. So suppose we could find an antiderivative capital F, then if we could, this definite integral would be capital F of 3x minus capital F of negative x cubed. And so then the derivative, a prime of x, would equal f prime of 3x times 3, as before, by the chain rule, minus f prime of negative x cubed times 3x squared, times negative 3x squared. Again, by the chain rule. So this is 3 times capital F prime of 3x plus 3x squared times capital F prime of negative x cubed. And now what is capital F prime? Capital F prime is this function right here, the sine of t squared. So we have to put 3x in for t, and in this part we have to put negative x cubed in for t. So we have 3 times the sine of 3x squared instead of t squared. We put 3x plus 3x squared times the sine of, instead of t squared, it'll be negative x cubed squared. And this simplifies. We can make it look a little bit nicer anyway. 3 sine 9x squared plus 3x squared times the sine of negative x cubed squared. Negative 1 squared is 1, so the negative drops. And then x cubed squared, you multiply those exponents, and you get x to the 6th. So the derivative of the area function, integral from negative x cubed to 3x of sine of t squared dt, the derivative of this function is this here, 3 sine 9x squared plus 3x squared sine of x to the 6th by the chain rule and the fundamental theorem of calculus. Okay, so there's a look at finding the derivative of an area function. Thank you for watching.